Question number 1. 1 to the power of 2015 plus 1 to the power of 2015. Well, that's just 1, and that's just 1. So we have 2, and the answer therefore would be B. From n piles of 12 coconuts each, I am able to make how many piles of 3 coconuts? So you have a pile of 12, and that can be divided into 3, 3, 3, 3. So that looks like 1, 2, 3, 4 piles. And therefore we started with n of these. So 12n would be 3n, 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 3n. So it looks to me like it'll be 4n in terms of how many piles. 3 coconuts each, right? So that would be D. Or another way to do it is just take 12n and divide by 3, and that would just give you 4n. So either way you get the same answer. X to the power of 400 divided by x to the power of 100. Well, you subtract. Exponent laws say that you subtract, so it'd be x to the power of 400 minus 100, and that is x to the power of 300. So that would be B. Negative 1 to the power of 1, negative 1 to the power of 2, negative 1 to the power of 3, and so on, all the way to the very end. Okay. Well, let's see here. So negative 1 to the power of 1 plus negative 1 to the power of 2 plus negative 1 to the power of 3, and so on. Let's put a few more in. And then I'm going to go to 97. 98, and then the last one 99. Okay, let's see what happens. So this guy is negative 1, this is 1, this is negative 1, this is 1. So as you can see, there's a little bit of a pattern, and then this one, because the exponent is odd, it would be negative 1, and then this, because the exponent is even, it would be just 1, and then the last one would be negative 1. So it looks like this would cancel, negative 1 plus 1, negative 1 plus 1, and then it would just keep going all the way down to that one at the very end, and then you'd be left with this solo negative 1. So this all boils down to just negative 1, and therefore number 4 would be C. If x squared minus y squared is 10, and x plus y is 10, x minus y is. So x squared minus y squared is 10, right? So if we factor that, it would be x minus y, x plus y is 10. Now they're saying that x plus y is 10, so this guy is 10. And therefore we just have to now divide through by 10, and then we get x minus y is equal to 1. So therefore x minus y is 1, and that would be 5 is A. And we have the total value of 2x nickels and x dimes is 60 cents when x is. Okay. So we have 2x nickels, so that's 5 cents. And then x dimes, which is 10 cents. And that is equal to 60, right? So that's 0.6. So this looks like 0.1x, and then that's also 0.1x, and that's 0.6. So that's 0.2x is 0.6, and when you divide through, you get x equal to 3. Therefore, number 6 is C. The least common multiple of 2, 4, and 8. So we have LCM of 2, but we have to put these in their prime factor form. So 2 to the power of 2 and 2 to the power of 3. So the way I remember it is least common multiple, think highest. I know it sounds counterintuitive, but that's how it is. Now, when I say highest, highest what? The highest exponent for each prime number. So the only prime number we have in there is 2. And then you think the highest, so the highest is 3 in terms of the exponent. So this is the LCM of these 3 numbers. And 2 to the power of 3, I believe, is 8. So number 7 would be B. 2 equals root 8 divided by. So we have 2 is equal to root 8. Well, root 8 is 2 root 2, right? And then divided by something. So that leaves 2 root 2 over 2, and therefore x is just root 2, right? So that would mean D. There are 6 more football players wearing dark helmets than wearing light ones. The ratio of dark helmets to light is 2 to 1. The number of light helmets is. Okay, so they're saying that D is equal to L plus 6, and then they're also saying that D over L is equal to 2 over 1. So that's part of the interpretation of the sentences. So this gives me D is equal to 2L, correct? And D is L plus 6, so I can just put L plus 6 here. And then solving this, L is equal to 6. So therefore, that would be C for number 9. The graph of something is parallel to the graph of 2x plus y is equal to minus 3. 2x plus y is equal to minus 3. So y is equal to minus 2x minus 3. So the slope is this guy right here. Slope is often denoted as m. So m is minus 2. So we have to figure out which one of these also has an m of minus 2 when the equation is written in this form, y is equal to mx plus b. Well, you can go through every single one, and you can see that hopefully you'll see very quickly that choice A, which is written as 2x plus y is equal to 3, when it's written in that form, it'll be minus 2x plus 3, and therefore for this one, the m is also minus 2. And because the lines are parallel, they would have the same slope. So number 10 would be A. We have consecutive integers whose average is x. The smallest is. Okay. So let's see here. We'll call them A plus 1, A plus 2, A plus 3, and A plus 4. And the average is x. So this x you just get by adding them and dividing by 5. When you do that, you'd get A plus 2. So this is x. So x is equal to A plus 2, and therefore the smallest is this guy, which is A is equal to x minus 2. So that means 11 is A. Of 5 consecutive even integers whose average is x, the smallest is. Okay, so a little bit different this time. They're this time giving you even, so it'd be A plus 2, A plus 4, A plus 6, and A plus 8. The average is x, so that means this guy is x. So x is equal to A plus 4, and therefore x minus 4 is equal to A. And that's the smallest guy, so that would be number 12 is C. The greatest common factor of 2 to the power 2004 and 2 to the power 2005. So this time we have GCF, greatest common factor of 2 to the power 2004, 2 to the power 2005. Now, these are already in their prime factor format. And then for greatest common factor, you think smallest. Smallest what? Smallest exponent of the prime factors. And in these two numbers, the smallest one is this guy. So that would be the GCF, 2 to the power 2004. So 13 is C. I ran away with a big prize when I was the 7th caller to know that the slope of every horizontal line is. So this is a horizontal line, and its slope, well, slope is defined, if you remember, rise over run, in case you forgot. Well, the run, let's say from this point to this point, what's the rise? Well, it didn't rise at all, right? So that rise is 0. And the run, well, the run, whatever it is, let's say it's some number, 3 or 30, it doesn't matter. But it's some integer, we'll just put n. Well, 0 over n is 0. So the slope of every horizontal line is 0, and therefore number 14 is A. 10% of A is B, then A is. So 10% of A is 0.A, is B, and therefore multiply both sides by 10, and we get A is equal to 10B. So therefore number 15 is D. For which of the following is n to the power of n the square of an integer? Now you can plug each of these in, but the only way that n to the power of n would be a square is if this is even. So 6 to the power of 6, for example, it would be 6 to the power of 3 all squared, right? That would make a perfect square. And therefore, that means this is C. K is equal to something, then the two roots of are equal. So you guys remember ax squared plus bx plus c is 0. X would equal to minus b plus or minus the square root of b squared minus 4ac, right? Quadratic equation, all over 2a. Well, the roots are equal if this guy is equal to 0. And that guy has a special name. It's called the discriminant. So the discriminant is b squared minus 4ac. And if that is equal to 0, this whole thing would vanish, right? And therefore you'd only have one root, or two equal roots. I mean, same kind of thing. Okay, so we have to set this equal to 0 using this equation. So that looks to me like 4 squared minus 4 times 1 times k, right? So that's 16 minus 4k is 0, and therefore 16 is equal to 4k, and therefore k is equal to 4. K is equal to 4, and therefore number 17, the answer is D. Jesse has worn the same hat for d years. If he wears it for 12 more years, he will have worn this hat for d squared years. For how many years has Jesse worn this hat? So the mathematical interpretation of that is that d plus 12 is equal to d squared. So we have to solve that. Shouldn't be too hard. D squared minus d minus 12. Let's see if that's factors. D, 4, 3, and negative positive. So therefore d is equal to 4. And therefore number 18, the answer is 8. All right, number 19. The absolute value of x plus the absolute value of minus x is equal to. Okay. Well, that depends, right? It depends on whether x is greater than 0 or x is less than 0, correct? Let's try both cases. If x is greater than 0, like for example, if x is equal to 5, this would be x plus, if x was equal to 5, this would be 5, and that would be minus 5, right? Minus 5, the absolute value would be x. So that would be 2x. Which is the equivalent of saying this. Okay, now when x is less than 0, so for example, if x is minus 5, this would be, this equation would be minus x plus, so this is going to be minus x. So that's minus 2x, or the equivalent of writing 2 absolute value of x, right? So for both cases, it looks like it's choice D. Circle C's center is 0, 0, and the length of C's radius is 5. Which of the following are coordinates on the circle of a point on C? Okay, so if the center is here and the radius is 5, so that's basically the graph. And the equation would be x squared plus y squared is 5 squared, right? Standard equation for a circle that's centered at 0. So they're saying which point is on C? Well, which one of these satisfies that equation? And looking through them, very quickly I can tell that the only one that seems to satisfy is this guy. And you can plug it in to verify. That would match. So 20 is 8. For primes A and B, if A is greater than B, then AB has how many unequal positive factors? So let's try 5 and 7. So let's let A equal 5. Actually, A is greater than B, right? So B has to be smaller than that. So let's try 5 and 3. Is that right? If A is 5 and A is greater than B, then B could be 3. And then A times B, therefore, would be 5 times 3, which is 15. And they're saying, how many unequal positive factors are there of this guy? So it looks to me like 1, 3, 5, and 15 itself. So if you were just talking in general about A and B, it would be 1, B, A, and A times B. So either way, you can see that there's 4 unequal positive factors. So number 21 is A. The product of something in x to the power of 100 has the same value as negative x to the power of 100. Okay, so we have some number times x to the power of 100, and then we have negative x to the power of 100. Okay, well this side looks, we can break it up into negative 1 to 100, x to 100. Well, negative 1 to 100, since 100 is even, that's just going to be 1. So really we just have this kind of a situation. And then the x to the 100s cancel, so the n is equal to 1. And I believe that is B for number 22. Square root of 16 to the power of 16. Okay, so 16 to the power of 16, instead of putting that square root sign, I'm just going to put the exponent as a half, because that's the equivalent to a square root. So then we use just basic exponent laws. 16 times a half is 8. So it's 16 to the power of 8, and they have given you that exactly in choice A. If the circle's area is 3600 pi, then its circumference is. So area of a circle is pi r squared, so that would be 3600 pi. So that leaves me with r squared is 3600, and therefore r would be the square root of 3600, and that I believe is 60, correct? Circumference is given by the formula pi d, and d is the diameter, and the diameter is also equivalent to 2 times the radius, 2r. So pi times 2 times r, which we calculated over here as 60, and that looks to me like 120 pi. So number 24, the answer is D. The cheapest way to move is by mail. So each time I move, I mail myself to my new home. I've done this as many times as the number of different integers that satisfy this equation. How many times did I move by mail? So, okay, so we got to find integer solutions to this, basically. Okay, I think I can do that. N squared minus 1, n squared minus 2, n squared minus 3, all is equal to 0. Okay, well, you can factor this guy, and then this one, n minus root 2, n plus root 2, and then n minus root 3, n plus root 3, all equal to 0. Now, if you look at these, the only one that is going to give you integers, because they specifically said integers, is these two. And they give you n equals 1 and negative 1. So that's 2 solutions, and therefore the answer to that question is 2, which is choice B. All right, we've got this algebra here. Let's see. 1 over x plus 1 over y plus 1 over xy is equal to something. I'll just put n for now over xy. Okay, so we got to add this. So top and bottom by y, top and bottom by x. Get common denominators to be y plus x plus 1 all over xy. And that's going to be n over xy. So then the xy's, the denominators cancel. So n is just going to be this top guy right here, 1 plus x plus y. And that is choice C for number 26. If the sum of the squares of two numbers is equal to the square of their sum, then the product of these two numbers must be. So sum of the squares of two numbers, we'll call it a squared plus b squared, is equal to the square of their sum. So here's their sum, and then you square it. So that's the interpretation of the sentence in terms of the math. So let's expand the right side, a squared plus 2ab plus b squared. This, and that all cancel, so then you just get left with this. And therefore, ab is equal to 0. Then a product of these two numbers, well, the product of these two numbers is right there, which is 0. And number 27 is A. So number 28, we have this whole thing minus this whole thing. Okay, so x squared plus 2x plus 1 plus x squared plus 4x plus 4 plus x squared plus 6x plus 9. And then we're going to subtract from that minus x squared minus 1 minus x squared minus 4 minus x squared minus 9. Okay, so this goes there, that goes there, that goes with that, that with that, this with this, and that with that. So the only thing we're left with 2x plus 4x plus 6x, and that looks like 12x. And therefore, number 28 is D. The number of fish that swam with me is the sum of the digits of the largest integer x, which satisfies x over x plus 1 is less than 2004 over 2005. How many fish swam with me? So we've got x over x plus 1, and that is less than 2004 over 2005. So we have to cross multiply, so 2005x, and then it will be 2004x plus 2004. So we got, let's see here, x is less than 2004, okay? They want the largest integer that satisfies that. So the largest integer that satisfies that is 2003. And then they want the sum of the digits of that guy. So that's going to be 2 plus 0 plus 0 plus 3, and that is 5. And therefore, number 29 is B. And for the grand finale, how many different integral values of B are both roots of x squared plus bx minus 16 integers equals 0 integers? So let's see here. Let's try to factor this. It could be x minus 1, x plus 16. It could be x plus 1, x minus 16. It could be x minus 2, x plus 8. It could be x plus 2, x minus 8. Or it could be finally x minus 4, x plus 4. Okay, so if we expand this, expand these guys, let's see what we get. We have x squared plus 15x minus 16, x squared minus 15x plus 16, plus 16? Sorry, it would be minus 16. I think they all have to be minus 16. X squared plus 6x minus 16, x squared minus 6x minus 16, and finally x squared minus 16. So the b in each of these, that's 15, that's minus 15, that's 6, minus 6, and 0. So I have 5 values of b, and therefore C is the answer to that one.